I am Carla J. Spuno and I will show you how I answered number 9, exercises 7.1. Our given, find each. We have A, B, C, D, and E. We need to find Z sub alpha divided by 2 for the 99% confidence interval, for the 98% confidence interval, for the 95%, for the 90%, and for the 94%. The symbol Z sub alpha divided by 2 is used in the general formula for confidence intervals. The Greek letter A, alpha, represents the total area in both tails of the standard normal distribution curve, and alpha divided by 2 represents the area in each one of the tails. Letter A, Z sub alpha divided by 2 for the 99% confidence interval. We have alpha, or the alpha level, the whole area or percentage, minus the given percentage. And it must be in the decimal form. And next, alpha divided by 2, we divide the alpha level by 2. And Z sub alpha divided by 2 is the critical value for the Z distribution table that corresponds to alpha divided by 2. First, we need to find the Z sub alpha divided by 2 for the 99% confidence interval. We have alpha equals 100% minus 99%, which is the given, and we subtract. Now we have 1%, and we divide it by 100. Now we have alpha equals 0.01, and we divide it by 2. Now we have 0.005. This is our alpha divided by 2. And now we look for the closest value on the Z table. We are looking for the closest value of 0.005 on our Z table. We have two closest value for our 0.005. 0.005 was not exactly on the table. Therefore, the closest values are 2. We have 0.0051 and 0.0049, and their corresponding values are negative 2.57 and negative 2.58. We go back on our problem, and based on our table, the closest values for 0.005 are 2. We have 0.0051 and 0.0049. And their corresponding values are negative 2.57 and negative 2.58. We subtract our value 0.005 to the closest values that we got, so we can determine their gap. We have 0.0051 minus 0.0050 equals 0.0001. And next, 0.0050 minus 0.0049 equals 0.0001. As we can see, they are same in gap, or the distance from our value. Therefore, we use both corresponding values to solve for Z sub alpha divided by 2. We are going to add the corresponding values and then we divide by 2. We have negative 2.57 plus negative 2.58 divided by 2 equals negative 5.15 divided by 2. Now we have negative 2.575 and equals negative 2.58. We have two decimal places. And therefore, the critical value of Z alpha divided by 2 that corresponds to the level of 99% confidence level is 2.58. Our answer will be positive. Our answer for the z sub alpha divided by 2 for the 99% confidence interval will be positive. On the given problem, the curve is not stated, so we assume that it is a normal distribution curve, which is symmetric, means the negative 2.58 has a positive value of 2.58. If you want to check if it really has a positive value, we subtract 1 to the alpha over 2. We have 1 minus alpha over 2, and the value of our alpha over 2 is 0.005. Now we have 1 minus 0.005 is equal to 0.995. And now we look for the closest value on the z-table. 0.995 was not exactly on the table, but the closest value is 0.9951, and the corresponding value is 2.58. Therefore, the 2.58 will be our z sub alpha divided by 2 for our 99% confidence interval. Therefore, our answer is positive 2.58. Next, we have letter B, z sub alpha divided by 2 for the 98% confidence interval. First, we are going to look for value of our alpha. 100% minus 98% equals 2%. And then we divide 2 by 100, so we get its decimal form. Now we have alpha equals 0.02. And next we are going to divide it again by 2. Now we have alpha divided by 2 equals 0.01. And next we are going to look for the closest value on the z-table for our 0.01. Remember, we are looking for the closest value of 0.01. We have 2. 0.01 was not exactly on the table, but its closest values are 2. We have 0.0102 and 0.0099, and their corresponding values are negative 2.32 and negative 2.33. We go back on our problem. Based on our table, the value or our value 0.01 has two closest values. We have 0.0102 and 0.0099, and their corresponding values are negative 2.23 and negative 2.33. We subtract our value 0.01 to the closest values that we got so we can determine their gap. We have 0.0102 minus 0.01 equals 0.0002. Next, 0.01 minus 0.0099 equals 0.0001. As we can see, the 0.0099 is closest from our value. Therefore, we are going to use corresponding value of 0.0099 for z sub alpha divided by 2. We have negative 2.33. Therefore, the critical value z sub alpha divided by 2 that corresponds to a level of 98% confidence in level is 2.33. Again, our answer will be positive. Next, we have letter C, z sub alpha divided by 2 for the 95% confidence interval. We have alpha equals 100 minus our given percentage, which is 95%. Therefore, we have 5%. And then we divide by 100 to get its decimal form. We have alpha equals 0.05. And again, we're going to divide it by 2. For our alpha divided by 2, we have 0.025. And now we are going to look for the closest value on the z-table for our 0.025. Remember, we are looking for our value the closest value for 0.025. 0.025 is exactly on the table, and the corresponding value is negative 1.96. Back on our problem, and based on our table, the 0.025 is exactly on the table, and the corresponding value is negative 1.96. Therefore, we use the corresponding value of 0.025 for our z sub alpha divided by 2. Therefore, we have negative 1.96. And our answer will be the critical value z sub alpha divided by 2 that corresponds to a level of 95% confidence level is 1.96. Next, we have letter D, z sub alpha divided by 2 for the 90% confidence interval. Again, alpha, we have 100% minus our given percentage, 90% equals 10%. And then we divide by 100 to get its decimal form. Now we have alpha equals 0.1. And we divide it again by 2. Therefore, we have alpha divided by 2 equals 0.05. And for our 0.05, we are going to look for its closest value on the z-table. Remember, we are looking for the closest value of 0.05. Our value 0.05 was not exactly on the table. The closest values are 2. We have 0.0505 and 0.0495. And their corresponding values are negative 1.64 and negative 1.65. Back on our problem, based on the table, the value 0.05 has two closest values. We have 0.0505 and 0.0495, and their corresponding values are negative 1.64 and negative 1.65. We subtract our value 0.05 to the closest values that we got, so we can determine their gap. We have 0.0505 minus 0.05 equals 0.0005, and next 0.05 minus 0.0495 equals 0.0005. As we can see, they are same. They are same in distance for our value, from our value. Therefore, we use both corresponding values to solve for z sub alpha divided by 2. We are going to add the two corresponding values. We have negative 1.64 plus negative 1.65 over 2. We have negative 3.29 over 2. Then we divide. We have negative 1.645, and then two decimal places, we have negative 1.65. Therefore, the critical value z sub alpha divided by 2 that corresponds to a level of 90% confidence interval is 1.65. And lastly, we have letter E, z sub alpha divided by 2 for the 94% confidence interval. We solve for our alpha, we have 100% minus the given percentage, which is the 94%. We have 100 minus 94% equals 6%. Then we divide it by 100 to get its decimal form. We have alpha equals 0.06. And we divide it again by 2. So we get the alpha divided by 2 equals 0.03. And we look for the closest value of 0.03 on the z table. Remember, we are looking for the closest value of 0.03. 0.03 was not exactly on the table, but the closest value is 0.0301, and the corresponding value is negative 1.88. Back on our problem, we have 0.03, and based on our table, the closest value is 0.0301. and its corresponding value is negative 1.88. Therefore, we use the corresponding value of 0.0301 to solve for z sub alpha divided by 2. Therefore, we have negative 1.88. Our answer will be the critical value z sub alpha divided by 2 that corresponds to a level of 94% confidence level is 1.88. Our final answer, we have this table for the confidence interval and its corresponding z sub alpha over 2. For the 99%, we have 2.58. For the 98%, we have 2.33. For the 95%, we have 1.96. For the 90%, we have 1.65. And for the 94%, we have 1.88. Thank you for listening.